Okay, so what we're looking at here is one of my projects, the YouTube counter LCD, which is based on a Wemos D1 Mini, but I've had numerous problems with it rebooting intermittently or simply not powering up on certain USB power adapters. Now this thing has been driving me nuts, but the problem is due to the voltage regulator on these clones. So I'll pull off, just put that to one side a moment. Now these clones, I actually ordered a genuine one off eBay, but a cheap clone turned up instead. And the problem you've got is this voltage regulator there. If you can see that one there, it's only rated at 150 milliamps, and your ESP8266 module can take a peak current of over 400 milliamps. So what that does is, as soon as it tries to show current, that regulator dips, causes the board to reset. Or if power dissipation is too high, it simply won't boot at all. It's a very common problem on these cheap clones. If you look at the regulator, there's a small code on it. Now this one, I've just measured the number, I can't see it, it's extremely small text. It says 4A20. Now if it says 4A with a number after it, 20 is probably the manufacture date or manufacture year. That means it's only 150 milliamp regulator, and that is almost certainly the problem with these. So in other words, all these cheap Chinese clones are never ever going to work properly. It's going to be very frustrating for hobbyists and the like to buy these things, because they wonder why their circuit keeps rebooting or it won't boot. They'll think it's a code that's at fault when all along it's actually this regulator. Now for inexperienced hobbyists, it can be a very frustrating experience. I haven't had much to do with these boards. This is the first time I've played with these, so I've come across this problem straight away. Now the seller on eBay just said just chuck it in the bin, but I've decided to try and repair it instead. So what I'm going to do is take that regulator off and put a different one on, and see if that makes a difference. Right, now with this being a surface mount component, it's very difficult to get off, so I don't have a... Well, I think I might just cut the pins. If I warm it up enough, it might just come off. It really pisses you off though when you get these cheap Chinese cones. Ah, there we go, it's come out. There we go. These cheap Chinese cones. It's a big problem. I mean, I don't know how I can get away with selling something that simply doesn't work. I mean, there's literally loads of sellers on eBay and Amazon selling the same thing, but they've all come from the same factory. You can see, just heating the pads up is taking that off nicely. Let's get that in focus. There we go. So, nothing actually wrong with this thing, but come on, focus. No, I'm not going to have it. Anyway, yeah. So fitting a cheap regulator it's just never ever going to work, and it just pisses you off really, because something needs to be done about this. It's cheap Chinese rubbish. They're just flooding the market. Now Wemos don't make this board anymore. That's probably why it's been cloned. So, but there's a lot of sellers selling these as genuine with a photo of a genuine one, when they actually send a clone like this. So it's not branded Wemos. So just to stand, it'll work, but I don't know. Right, let's try and repair this thing then. What I'm going to do to repair it is use this AMS 1117 3.3. Comes on the pre-built module, which was actually cheaper than buying the chip itself. Comes with the smoothing capacitors as well. This will fit just nicely under the board. So I'll try and solder this in place. Question is, where am I going to fit it? I could fit it on the veroboard actually. Yeah, I think we'll do that. It would go under there just nicely. No, it's not going to fit. Right, okay, so I'll fit it onto the prototype board instead. Come off. You can see what I've done with this LCD here is put some resistors there across to increase the backlight brightness, because the 5 volts is only at 4.5 volts, which there's a reason why this LCD panel fails to initialize sometimes. So hopefully doing this mod will bring it back up to 5 volts, or well 4.8, which is a diode in series with it. I can take the resistors off and it should work. First of all, we just need to do some basic circuit checks and make sure the 5 volt is actually connected to the other side of that diode. Oh, that's my bad. It's this side I want. So that goes to your USB connector, and that one should go to your 5 volts, which it does. So 3.3 should go to none of those. Ah, that one. Right. Okay, so there's no short circuits on the board. Right. Straighten that up. So it looks neat. Yeah, let's cut those off. Right, now we need to just solder some wires from the input and output to 5 volt and 3.3, and obviously the ground, and that should do it. Okay, that's one wire on. One thing you've got to be aware of is these AMS 1117s don't have the same pin out as a 7805, so just be aware of that. Right, solder the rest of the wires now. Right, that's another one. Not the neatest of jobs, but a quick continuity check. What I'll do is I'll put a link down below to the Reddit post that describes all the different voltage regulators that I use on these clones, because some do come with capable voltage regulators. There's some rated at 150 milliamps, some rated at 300, and there's some very rare ones that do actually come with ones that can handle the full load. So if you're ever going to buy one of these Wemos D1 minis, Might be worth asking the seller what sort of voltage regulator's on it, because otherwise you'll be stuck with something that simply won't work and can't ever work unless you do this modification. Replace the regulator with a decent one. So there's just one more wire to solder, and then we'll give it a test. Right, so what I've done here is ground, obviously goes to ground, the input goes to the 5V pin on there. It is actually soldered to the bottom of that pot, but there's a wire going from the 5V pin on the other side of this board to there. So the input goes to your 5V pin, output to your 3.3V pin, and your ground to ground. Obviously, don't forget to remove the old regulator and make sure there's no shorts between the pins. So you have 3 different colour wires there, green for ground, red for input, and blue for output. So that should be ready to test now. Right, well, as you can see, that works. I just need to do a quick voltage check of the 5V rail. See if it is actually, see if it's not 4.4V anymore. Because they haven't used, again, they haven't used a Scotchy diode, they've used an ordinary one, so that drops it by 0.6V instead of just 2V, 0.2V rather. So what's the 5V rail at now then? Still only 4.5V. That's not quite, something not quite right there then. Must be a massive voltage drop across that input fuse. More importantly, does it work on a device that it didn't work on before? So I'll give it a try now. Okay, right, that didn't work. Still won't boot. Now we're looking at the schematic. The CH340 is powered from the 3.3V supply. It's recommended it's powered from the USB supply according to the datasheet. Now this chip controls the RTS and CTS lines which connect to these 2 transistors here, which in turn hold the boot pin low. So if you connect a serial terminal emulator to it, you can see that it never gets past the bootloader because that pin, the flash pin, is being pulled low. So that's just due to a bad design. There's just no way you could have better fix that really. So as soon as that 5V rail goes above 4.5V, the board won't boot. So if you have, say, an output, a power bank that outputs 5.1V, which is within tolerance, the board won't boot. So I don't know how I'm going to fix this without extensive modification. Just altogether it's a bad design. Bridging that diode obviously makes it not boot at all on anything, because that brings your 5V supply too high. So I can't see how these things can ever work. Maybe 3.3V only. If you're trying to run a 5V LCD off it, well, an LCD that needs a 5V supply but will work on 3.3V signal inputs, then it's not going to work properly. Okay, I'll have to come back to that one, I think. Right. The way this circuit works, this transistor here is the thing that handles the flash pin, which is D3 or GPIO 0. That chip does a reset, so you can issue a reset command through the serial port, and that one handles the flash pin. The way around that problem is probably to take that transistor out. The only problem with that is you'd have to have a physical button attached to D3. Every time you want to flash it, press and hold that button. That'll put it into flash mode. I'm just going to test that theory by taking that transistor out and seeing if the board boots. Connect it to my PlayStation, so it outputs 5.2 volts. With the board and boot, if I take that out and it boots and I get 5 volts, and that's almost certainly the problem. Now while I wait for soldering iron to warm up, I'll just say the NodeMCU boards work perfectly fine. They're still available, and they're a lot better. I mean, this regulator that I fitted will solve the intermittent resetting problem for sure, but it certainly won't fix this issue. The NodeMCU boards just work great, not a problem. So these Wemos clones, I'd stay away from them. Well, they're good because they're smaller, but you know, they simply don't work. You know, they're selling something that don't work. A complete waste of time, really. All you do is end up pissing about, wasting your time. So what I'm going to do with this one, I'll take that transistor off, and if the board boots, it boots. But the problem is I won't be able to program it, so I'll have to put a little jumper switch, probably a little push button switch between D3 and ground, and hold it down for a few seconds. That will enable the board to go into boot flash mode. That tells the bootloader to wait for an instruction to flash it rather than continue boot. So give that a go, and then we'll see what happens. Okay, so that's been removed. Let's give it a try. Try it in the power bank first. There we are. Right, so it still works on that. Right, let's give it a try on the PlayStation. Right, still won't boot. I tried measuring it with a scope, but I just can't see. It's starting to rain now, so it's getting a bit dark in here. Okay, right, well that still didn't work. Removing the transistor for the reset circuit. Now that's gone skidding across my worktop and I can't find it, so not really a problem, so just manually reset it, that's all. I'll just bridge out that diode, just temper it just so I can do a bit of fault finding to see why the board won't boot. And I'll put it on my PC and see if I find out why it won't work. Right, so I've got a full 5 volts going in there now. As you can see, the LCD doesn't initialise. What I'll do is just check what state the pins are in. So let's check these voltages. So 5 volts, you should have 5 volts exactly. 3.3 volts, we have 3.3. Now the flash pin, which is D3, that's at 1.9 volts. Your reset pin, 3.3, so that's been held high. Right, okay. Right, so I'll connect it to a computer. Fortunately I can't capture it, the Arduino output, but yeah, it's stuck in, the bootloader's stuck in flash mode. That voltage on that pin is 2, and it's pulling lower. So it's an inherent fault with it, basically. Okay, I've looked at the schematic. Pin D3 should be pulled high, not pulled low. D8 should be pulled low. Wemos D1. Oh, that's got 10k resistor to ground. D3's got a resistor pulled low, so that should have a 12k. That should have a 10k resistor to 3.3 volts, which it does. So that pin is being pulled low from an external source somewhere, causing it not to boot. Just wonder if it's that transistor. Yeah, it is. Is that transistor faulty? Doubt it, but let's see, all the other boards I bought are the same. Certainly that new regulator will stop the intermittent reset problem. Oh, it's still there. No, it must be external components. Sometimes the only way you can tell is take the transistor out of circuit to test it. But yeah, let's try it again, see if the board boots. Yeah, it's something to do with that CH340 that's doing it. And the board still doesn't boot. Right. I'd just like to mention as well, it's nothing to do with the LCD panel because this board on its own won't boot when connected to the computer. So a lot of you will be thinking that it's something to do with the circuit I've connected to it, but it's not. Just a bare board on its own won't boot. It's starting to get dark now, so I'm having difficulty soldering that transistor on, so I'm going to have to leave that one for another day. What I'm going to do is just try improving this. Hit pin D3. It's that one. This is going to be a sacrificial board, so just bend that away. Where's my thing? So what I can do is connect a pin. If I want to flash it, I can just connect a pin. I remove that transistor, I can just connect that pin there to ground. Temporary if I want to reprogram it. Which, hopefully now the thing should work. And it doesn't, so what's the other show what's going on here. Measure the voltage on that pin. Oh, that 12k resistor to ground has gone. Yeah. 1.9 volts is probably low enough to see it as a logic 0, so needs a stronger port resistor. Bizarre. Let me try that. Okay, I've just fitted port resistor to 3.3 volts on that pin. That makes a difference. Nope. What voltage are we getting on that pin D3 then? Still 1.8 volts. Right, I've got 220 ohm now to 3.3 volts. Not booting. Check the voltage again. 2 volts this time, that's weird. Something's pulling that pin down. But there's nothing connected to it. Okay, so I paused the recording and then forgot to unpause it, so about half an hour of recording is gone. So I'm really pissed off with it now. So I just smashed the shit out of it instead. This cheap, crappy Chinese rubbish. Well, I don't know what to do now, really. Well, there's only one solution. Oh, so this is the only solution. That is what I think of cheap Chinese crap. Okay, so to conclude, it's definitely worth replacing that voltage regulator because it will solve the intermittent resetting problem. But it's beyond me what's causing the board not to boot if the supply voltage is above 4.5 volts, but below 5 volts. There's only one thing really left to do now. Now if you look carefully, there's a slight addition to the pile of wood I used to start my fire. There we go, good riddance to Chinese rubbish. Well, there is one good use for those Wemos D1 minis. They make great firelighters. Thanks for watching.